point and pulled with the directions and magnitudes shown. What is the resultant force on the point? So, what we're doing here is we're adding the pull and um the resistant force together. So we're doing basically the same thing we've been doing, but it's more like a word problem. So on the left side, we've got a triangle that has a hypotenuse of 70, has the acute angle is 45 degrees. On the right side, we have a hypotenuse of 40 and the acute angle is 30 degrees. So we're going to go ahead and work this problem um, just like we've done before. I've gone ahead and worked it to kind of save time so you guys don't have to sit there and watch me doing all the calculations. But basically, we have a 45-degree angle. We do the cosine of 45 degrees equals adjacent over hypotenuse. The cosine of 45 degrees is this. Multiply that times 70. And that gives us 49 and 49 hundredths. Rounds up to 49.5. You notice that it is to the left, correct? So that means it's going to be a negative R, so negative 49.5. And then when we redo it using sine, it actually has the same, it's the sine of 45 degrees is the same as the cosine of 45 degrees. So you end up getting the same thing, 49.50, except for it's u. Okay. So I have that written down here. Then you do the right side where we have an angle of 30 degrees. The hypotenuse is 40. So going to the right is going to be a positive to the right, and it's going positive up. So the cosine of 30, thank you, degrees equals adjacent over hypotenuse, 0.866025404 times 40 is 34.64101,615. So rounded to 34.64, it's positive. And then when you do the same thing for the sine, you get a 0.5 as the sine of 30 degrees. You multiply that times the hypotenuse, which is 40, and that gives you a plus 20. So we add those together. Oops. And we get this negative 14.86R plus 69.50U. Okay, we're not done. From here, you have to find the express so this is the resultant force. So you've got to express this in polar coordinates. So we have to put it back into polar coordinates. So this is a negative 14.86. So we're going to the left, 14.86. Then we're going up 69.50, right? And then that goes back down here. So if this is on a coordinate plane, that's what it looks like, right? So we're trying to find the angle from here to here to tell people. So the point of the vector is to find the location of this point, right? So we have to find the angle from here to here. So we can do that by using tan. We can use tan because we have the opposite and we have the adjacent length, right? So we can say tan equals opposite over adjacent. So we just put that in. 69.50 divided by 14.86. Okay, where'd my get your calculator out? Where'd I put mine? Oh, I left it on the table. Oh. Okay, Pat, what'd you get?
Give me a second. Hard to see the screen.
69.
4.68.
So Tad got 4.68. So I'm leaving it in my calculator and I'm doing second and then hitting tan.
Oh, it's not that.
So I got an angle of 77.93 degrees. So that's what this angle is, right? 77.93. Okay, somebody. I think Belle's having a hard time. And then,
I bet she left so that she can go play in the snow.
yes, I'm sure everybody would rather be playing in the snow right now. Okay.
Sandy can't homework.
Miss Angie's the
Miss
best
Angie's the
teacher.
best.
Yes, Miss Angie is the best. Miss Angie's playing in the snow. Okay, so this is the 77.93 is the angle of this triangle. So the distance between here and here is going to be the difference between what and 77.93 tag.
Sorry, say that again.
What's the distance between here and here? If this angle is 77.93, what's this? Brinkley.
2.07.
Okay, you looked in the book. All right. So we know that from here to here is 180 degrees. So the difference between this
Oh,
and this.
oh. No, I'm sorry. I didn't realize that. I thought that was the angle of the line. Sorry, that's my fault.
Yeah, no, that's okay. So 180 minus 77.93 equals 102.07. So now we just need to find the distance of the hypotenuse, right? So the hypotenuse is here. Jackson Wright, are you there?
Yeah.
So tell me how you would find the hypotenuse for this. What would you do?
You keep cutting out. Hold on.
I'm cutting out. Okay.
Yeah.
So I'll ask again. How do you find the hypotenuse of this triangle?
I don't know.
Okay. Brinkley, what do you think?
You have to square the answers for R and U.
That's right. So you're going to use the Pythagorean theorem to find the answer. So a squared plus b squared equals c squared. So everybody go ahead and try and do that. The easiest way to do it in your calculator is to do, you could put 69.5 in, and then there is an x squared button that will go ahead and square it for you. And then what I've been doing is I just write it down. The square is 14.86 squared, 220,
220.9.
0.8196.
Yeah.
Okay. So you add those two together, which I'm going to do this.
Oh, wait, no, I'm sorry. Pretty cool. 5,051.06.
Yes. So it should be 5,051.0696. Then you take the square root of that, which if it's still in your calculator, you can just hit the square root button. And that gives you 71.07. So that's the distance. So your polar coordinate is going to be 71.07 at 102.07, which was what we got for the angle for between here and here. Okay.
I was able to do that on all my calculator.
Were you able?
But you wrote it down like.
Well, you probably can. I just don't have a brain that does that. So
No. I'm saying that like I took the.
Did you put in parentheses?
No, I didn't. I just did this.
Uh-huh.
Then I. Yeah, that was right.
And then you hit plus.
And then I hit plus, and I wrote out
the 220.
28.
96.
96.
And then you squared it.
And I squared it again, and then I hit equal.
Uh-huh. And then you took the square root?
Okay, that time I got a different answer, but the first time I got the right answer.
Okay, that's fine. All
I
right.
think I mispressed it because I was looking while I was typing.
Okay. All right. Landon.
Or Landon.
I
His
know.
mom's outside right now and he wants to go.
Yeah. Hey, Landon.
Yep.
Has your microphone has this been cutting in and out for you when you're listening?
Not really.
Okay. Did you understand what we just did?
Somewhat.
Somewhat. Okay. Thank you. Jackson Wright. Not Jackson Wright, sorry. Jackson Weigel.
Yeah.
Did you understand it?
Yeah.
Okay, perfect. Katie.
I understood it.
Okay, perfect. Oh, wait a minute. I forgot my last person that I like to read the room with. Paul. What did you think?
That made sense.
It made sense. Okay, let's go ahead and do the next one then. 78.2. So on this one, we've got a point that's acted on by a push force and a pull force. So we've got 10 to the right, and then we have one that goes 16, and then it has an angle of 30 degrees here. Okay, so first of all, this push right here doesn't have it doesn't have an up, right? It's just to the right. So we know that that's just going to be 10. It's a positive 10R plus a 0U. Okay, so that's our first one. And then the other one, we know it's 30 degrees. So we can say cosine of 30 times the hypotenuse of 16, right? So that's going to be 13.86R. That is to the right and up. So this is positive. So positive R. And then the sine of 30 times the hypotenuse is going to be of 16 is going to be so it's 0.5 times 16, so it's 8U, which is also positive. Okay, so then we need to add that to our 10R plus 0U. So this is 13.86R plus 8U. So when we add that together, we're going to have 8 up and then 23.86R. Okay, so part 2 to this is expressing this in polar form. Okay, and let's see here. Who can? Anna Lauren, what should I do first to figure out what the polar form is?
I don't know.
Okay, so first thing I'm going to do is I'm going to take my directions and I'm going to draw it on a like it's on a coordinate plane. So since this is positive, I'm going to start I'm just going to draw a line to the right, and then I'm going to draw. So that's 23.86, and then I'm going to draw a line up, which is 8U. Does that make sense to everyone? Side, does that make sense?
Yes.
Okay, so now I just draw my line back here and I have my right triangle. So I need to find the hypotenuse. That's going to be the distance for my polar coordinate, right? The distance right here. And then I need to find my angle. So the way I find my angle is because this is here on the coordinate plane, whatever angle this is the distance from here to here, right? So I know that I can use tan to find this. So Tag, what's the ratio for tan? Tan equals whatever what? So to recap, sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. What does tan equal? You guys are supposed to have this memorized. What are you doing? Looking it up every time?
Yeah.
Don't look it up every time, memorize it. Somebody tell me what the ratio for tan is.
Opposite over adjacent.
Yes, opposite over adjacent. So,
Say that.
so then you just fill that in. So Brinkley, what is my ratio going to be?
1 second.
I don't mean what the answer for tan is. I just mean what am I putting in here and here?
Oh, you're gonna put 8U on top and then 23.86 on bottom.
Right. And then what does this mean? It just means that I divide, right? So I'm just dividing 8 by 23.86. So 8 divided by 23.86 equals 0.335289187. I'll just leave it in my calculator. And then I'm going to hit second and tan, and that will give me the angle. So my angle, that inverse tan gives me the angle, which is 18.54 if I round it to two places. Okay. So my angle is 18.54 degrees. Okay. And then Jackson, right, tell me again what I'm going to do to find the missing side for the distance. I might have lost Jackson. Okay. I'm going to use the Pythagorean theorem. So I know that this is 23.86 and I know this is 8. So I'm going to square this. I'm going to square this. So this was, make sure I did that right. 23.86 squared is 569.2996. And then 8 squared is 64. Add those together. 569.2996 plus 64 equals 633.2996. And then I'm just going to take the square root of that. So that gives me 25. And if I round it to two places in 1700ths degree, not degrees, sorry. 25.17. So it's 25 and 1700ths. So this is our answer, set 25 and 1700ths at 18.54 degrees. Okay, so I want you guys to apply this to the practice problem. So let's everybody get your thinking cap on, and let's get started on practice problem A.
There's no A.
Okay, it's by default A since there's no letter there. Let's get started on the practice problem and pay no attention to the man behind the curtain. All right.
Everybody's leaving.
I think that they're just having problems with staying in. Okay, so this is the hypotenuse on the left, hypotenuse on the right. It's 58 degrees here, 22 degrees here.
Back around.
Okay, so I am taking 58 degrees. I'm hitting my sine button. I'm sorry, not my sine button. Doing 58 degrees, hitting my cosine button, which gives me.
Do you mean to write sin down there?
Do
you mean to write?
I did. Thank you. I'm trying to change my order so that it's in the right thing. Sine.
So it's to send that we have to do this.
Times 40. So this is 21 point 20. Had to go to the left to get here. So this is a negative R. Chink. So it's a left. Okay. And then 58 sine times 40 is plus 33.92 U. Thirty 82, and that's to the right. Thirty 11.24 U. All right. What did you get, Tag? For those, did you get the same thing I did?
Still playing through them.
Okay. Sai, are you there?
Yes, ma'am.
Did you get what I got so far?
Yes, ma'am.
Okay, perfect. Oh, of course I picked the solution manual that does not have the answers in it. No, it's okay. Okay. So 27.82 minus 2120 is 6.62 R. It's so crazy for it to be dead silent. These two guys chattering the whole entire time.
No,
Okay.
that's mostly landed.
Yeah, no. 662 R 0.45. Okay. All right. This is also what's in the answer key. So hey, Belle. Okay. So now that we have this, part 2 is expressing this in polar coordinates. So we're going to just follow the directions. To the right, 6.62 R, right? And then up 45.16. Then we're going to draw that back here. Okay, so we can find the hypotenuse by squaring both of these. And then taking the square root of their sum. So 45.16 squared plus 6.62 squared. We add those together.
200, 2083.25.
That's what I got too.
Did it?
And excellent. And then take the square root of that. So the square root of that would be 45.64. Okay.
Yes.
So that's the distance, 45.64. So now we just need to find the angle. So like Brinkley said, we have the dimensions to use tan because tan equals opposite over adjacent. So we just need to divide 4.16 by 6.62. 4.16 by 6.62, which gives us 6.821752266. And then we do second tan, the inverse tan, to get the angle, which is 81.66 degrees. And that is also what the book says. Okay. All right. So now I want you guys to do number 12 in the lesson to show me that you can do it all by yourself. So everybody get started on that.
Number 12.
Number 12 on page 326. Hey, hon.
Square that. Sorry, take the square root.
Take the square root of it. Okay. And then see if I've got the right answer here. What number is this? 12. Okay. How did everybody do?
Great.
You did great. Excellent.
Great.
Great. Okay. Everybody chime in, please.
Fantastic.
We did good. Good.
Good.
Excellent. 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 Okay.
Good.
Excellent. Okay. So let's go ahead and move on to metric volume and 45, 45 degree, 45, 45, 90 triangles. So metric volume is just using metric instead of standard English units. So
I don't like the tricks.
you don't like metrics. So if we've got,
Makes me feel less American.
well, first of all, you probably already know this from if you're taking chemistry. Look at the bottom. See that 1 cubic centimeter is equal to 1 milliliter. It's a very helpful conversion. Something you need to memorize, just like memorizing that 2.54 centimeters is 1 inch. So go ahead and kind of figure that out in your head so that you can use that. If you're not in chemistry yet, you'll need it later. So when we convert volume, it's necessary to use 3-unit multipliers for each step in the process. So for example, when we convert 7 cubic meters, so that's 7 meters cubed, to cubic centimeters, then we're going to go from this, and then we need to have meters times meters times meters, right? And then 100 times 100, times 100, because 100 centimeters equals 1 meter. So you have to do it 3 times. This is going to cancel, and then you're going to multiply across, which you just count the zeros 1, 2, 3, 4, 5, 6. So 7, 1, 2, 3, 4, 5, 6 centimeters cubed. Okay. Now, if you realize that that centimeters cubed, that 1 centimeter cubed is equal to 1 milliliter, then you can go from centimeters to milliliters very easily. Okay, you could just say, oh, this is the same as 7 million milliliters. Okay. All right, so let's turn the page. So you'll use cubic centimeter and milliliter interchangeably because they're equivalent. So on example 79.1, use unit multipliers to convert 14,000 milliliters to liters. Okay, so we start with the 14,000 milliliters, and we're going to liters. So 1 liter equals 1,000 milliliters. So we're going to put milliliters in the bottom and liters on top. So 1 liter, 1,000. This cancels, this cancels. You're going to divide by 1,000. So that's just going to be 14 liters. All right. So as long as you know what the equivalencies are, you won't have any trouble with these. So 4 cubic feet to liters. You can see where this is going, right? We're going to have to go from feet to centimeters. So in the centimeters cubed will go directly into milliliters, and then from milliliters we can go to liters. So 4 feet cubed. So we're going to have feet cubed here and go from feet to inches. And then you're going to have to go from inches to centimeters. And then you can go from centimeters cubed to liters. Inches, did I miss something? Inches, centimeters. So milliliters to liters. Okay. So there are 12 inches in a foot. So 12 inches cubed. And there are 2.54 centimeters in an inch. So you have to make sure you cube each thing. And there is 1,000 milliliters in a liter. All right, so this cancels, this cancels, this cancels, this cancels, and this cancels with this. So this is going to be 4 times 12 cubed times 2.54 cubed over 1,000 liters. Okay. Sai, how are you feeling about that?
That's feeling
Great.
You're feeling great. All right, excellent. Katie, how are you feeling about it? That didn't sound good. All right. I'm going to assume everybody's great unless you're speaking up and saying you're not great. And we're going to go ahead and go to example 79.3. So 4.7 liters to cubic inches. So 4.7 L over 1. So we have to go from L to milliliters. So there is 1,000 milliliters to 1 liter. Okay, well, this is the same as cubic centimeters. So we're going to do that. And we're going to do 2.54 centimeters cubed, cubed to inches cubed. So there is 1 cubed. All right, so liters cancel, the centimeters cubed cancel, and you're going to have 4.7 times 1,000 over 2.54 cubed, and it's inches cubed. Okay. All right. Last thing for this lesson is 45, 45, 90 degree triangles. So remember, this is another one of those triangles that you need to memorize what the dimensions are for similar triangles. So if you have a triangle that has a 45 degree angle here, then the other one's going to be if it's a right triangle. If one of the acute angles is 45 degrees, then the other one is 45 degrees. And since you know that those are both 45 degrees and that there is that the sides have the sides will be it's going to be an isosceles triangle because the sides are both going to have the same length. We know that that it's going to be you need to memorize that this is 1, and this is the square root of 2. And then if you have another triangle that's 45, 45 degree, 45, 45, 90, you can use these proportions in order to solve for the similar triangle. So for example, 79.4, we have this triangle where this is X, this is Y, and this is 7. It's given that this is 45 degrees. So you know that the proportions for a similar triangle are going to be this, and you can use these ratios to find the missing sides. You can say, so 1 is to X as square root of 2 is to 7, and you can solve for this. So X times square root of 2 equals 7. And this, so x would be 7 square roots of 2 over 2 is what x is. And then you can also find y. 1 is to y as square root of 2 is to 7, cross multiply, square root of 2y equals 7. And you can't leave that in that square root in the denominator, so that's why we're multiplying both the top and the bottom by square root of 2. So 7 square roots of 2 over 2. So, well, actually, I didn't have to really do that because both of the sides were the same. So I should have known that x and y would be the same anyway because they're the same length. So sorry, I did it twice. Okay, so let's do the practice problems for these. So actually, if you look at practice problem C, since you see that one, it's an
They're the same.
you know that it's an isosceles triangle, so you know that if the one side is 3, then just like Tag just said, y is also 3. So you only have to find the hypotenuse of that one. All right, everybody go ahead and do that, and then we'll check your answers. And then we'll be done. Are you done already, Tag?
The first two. Give me a second. And so, oh, well, then I already know what. Can I use a different method to get C? Because
You could just use the Pythagorean theorem.
yeah, because if 3 equals x, let's just say x, then y would also equal 3. And
Right.
then you just, okay. So 3, 2. Okay, got it. I'm such a genius.
Yes. You are
Okay, wait.
so genius.
Is this for these answers?
Should be. Yes. 12.
Check this.
No. You've got your numbers in the wrong place on B. And C should be y equals. What's your answer for C?
Z is 18, y is 3.
Z is not 18.
Z is 18 though. Because if you use the Pythagorean theorem, 3 times 3 equals 9. 9 plus 9 is 18.
And that's C, so that's C squared. But what's C?
Four point two four.
It needs to be in a radical form.
4.24 over 1.
You need to find the radical form.
Like an half credit for that?
No,
That was worth half credit though.
it was not.
That was.
It was
I,
not.
I say that we asked the class.
I think the class just wants to finish so they can go on about their day.
What interesting things could they even do today?
I don't know.
What would they even want to go do?
I don't know. 8. Oh, what am I doing? Hold on. Inches cubed. Which is cubed.
You parasite!
Centimeters cubed. So 12 cubed. Um, Compute 2.54 cubed. Dink, dink, dink. So 10, 12 to the third, 2.54 to the third, over 1,000 liters, I think.
That's right, Miss Charlotte.
Thank you. All right, and then C is 3, y equals 3. And then if we use our 3 is to 1 as z is to square root of 2, then it's going to be 3 square roots of 2 equals z. So did you get C, Zach? I mean, tag? Sorry. I'm sorry.
Don't call me Zach.
I'm sorry.
You're like-
Okay, so if you use the the similar triangle, all you're doing is doing 3 is to 1 equals z is to square root of 2 and cross multiplying, and this is the correct answer. So if you do 3 times, okay, 9, so you did 3 squared plus 3 squared equals c squared. So this would be 18 equals c squared, right? So if you take the square root, then all you have to do is simplify this. 2 is 9, 3, and 3, right? So that's 3 square roots of 2. Do you remember how to do that now? Okay. All right, everybody chime in and let me know whether you did okay on the practice problems. As soon as I hear,
I got it.
got it. All right,
I
homework.
got it.
You got it.
Got it.
Good.
I got it.
Good, good, good. All right. So homework is 78, 79, and test 18. Oh, is it test 18 or 19?
19.
Test 19. Okay. And if anybody has any questions or problems, just let me know. You can send me a message in Google Classroom or text me in a group text with your parents. All right.
Thank you.
All right. Thanks everybody for showing up. I will see you guys, Lord willing,
Thank you.
on Tuesday.
Thank you.
You're welcome.
See ya.
Have a great rest of your day.
Dang.
野马飘飘，冰封进心头。
Get
Out.